You know, every single line of code we write eventually has to face its toughest test, the real world. So today, we're diving into the final critical stages of application security. We're talking about what it takes to secure that last gate and protect your software when it finally leaves the nest and goes into production.
And that quote, man, it just hits the nail on the head, right? Deployment is the moment of truth. All that careful planning, all your brilliant code, it all gets put to the test the second it goes live. Your app goes from being a safe little project in a controlled space to a live service, exposed to literally every real-world threat you can imagine.
I absolutely love this analogy because it just works so well. Okay, so picture this. Your source code is like a bunch of passengers waiting to board. Your CI/CD pipeline, with all its automated checks and scans, that's airport security. And production, well, that's the plane, in mid-flight, exposed to everything. If even one little thing fails in that security checkpoint, a vulnerability gets on board, and we all know how catastrophic that can be. So before our plane can even think about getting to the runway, it has to pass through a series of increasingly secure zones. In the software world, we call these deployment environments. Let's break them down. A deployment environment is way more than just a different server. You should think of it as a totally isolated bubble. It's got its own infrastructure, its own configuration, its own data, and, this is the really important part, its own unique rules and its own level of trust. The main thing to get here is that each of these environments has a very specific job and a completely different audience. We start in development. That's the developer's sandbox, which, let's be honest, is usually a bit of controlled chaos. Then it's on to testing, where QA teams and automated pipelines get their hands on it. Staging is like the final dress rehearsal, where business teams give it the once-over. And then, finally, production, the live, high-stakes system that our actual customers are depending on. And that brings us to an absolute golden rule, the principle of data minimization. Seriously, if you remember one thing from this, let it be this. One of the single biggest causes of data leaks is using real, sensitive production data in less secure environments like dev or test. It's really that simple. What's used in production stays in production, period. All right, so we've mapped out our secure zones. Now let's talk about the gauntlet. These are the relentless, unforgiving tests our code has to survive before we would ever let it get near a real customer. You can basically split security controls into two big buckets. First up, you've got your preventative controls. These are your walls, your locks, your barriers, things like a web application firewall or strict access rules that are designed to stop an attack before it can even get started. But then you have your detective controls. Think of these as your security cameras, your alarm systems, tools like vulnerability scanners and log analysis that are designed to spot an intruder who might have already slipped past your walls. And you absolutely 100% need both. Now, this is one of my favorite bits of trivia. The term smoke test. Where does that come from? It actually comes from electronics. When you power on a new circuit board for the very first time, if smoke starts pouring out, you know you have a catastrophic failure. There's no point testing anything else, right? It's the exact same idea in software. Smoke tests are just these incredibly simple go, no-go checks on the absolute core functions. Can a user log in? Does the homepage even load? If these basic things fail, the whole deployment is a bust. We roll it back immediately. It's our first line of defense to make sure the whole thing didn't just catch on fire. Okay, next in line is user acceptance testing, or UAT. And this is a really important shift, because here, the business team, the actual people who are going to use the software every day, get to play with it in the staging environment. Their job isn't to find technical bugs, it's to answer one simple question. Does this thing actually do what we asked for? This is the final business go or no-go before we launch. So the code works, the business team is happy, we're good to go, right? Well, not quite. Now we have to ask some different questions. Is it fast enough? Can it handle the pressure? That's where performance testing comes in. Here, we're basically trying to break the system to find its limits when it comes to capacity, speed, and stability. And this comes in a few key flavors. Load testing simulates a normal average day of traffic. Stress testing is way more brutal. We push the system until it breaks just to see how it breaks. This is super important for understanding how it might survive something like a denial of service attack. Spike testing is for those flash sale or viral moment scenarios. And canary tests? These are really cool. We roll out the new version to just a tiny fraction of real users in production, and we watch it like a hawk to see if anything bad happens before we give it to everybody else. So let's recap. The code is passed every single test. It's live, in production, we can all go home, right? Not even close. Honestly, in a lot of ways, this is where the real work is just beginning. Because security isn't some one-time gate you pass through. It's a nonstop process of protecting a live application in a hostile, ever-changing world. Here's the truth. Every system we build is based on incomplete assumptions, and new threats are popping up every single day. We have to be humble enough to accept that we're not perfect and we can't possibly predict everything. And that is exactly why we have to be watching, constantly. That's why we monitor. Monitoring is what moves us from static, pre-deployment checks to active, real-time control. It gives us actual evidence that our security is working, which builds trust and keeps the auditors happy. But most importantly, it creates that essential feedback loop that is the absolute engine of the entire DevSecOps philosophy. So what's at the heart of any monitoring system? It's the rule. And a rule is really just a simple statement about how the system is supposed to behave. It's our definition of what normal looks like. And when the system does something that doesn't fit that rule, boom, a violation is triggered. And look, this doesn't have to be super complicated. A monitoring rule can be as simple as this. If this one thing happens, then that other thing must happen within a certain amount of time. If it doesn't, something's wrong and we need to raise an alarm. That's really the core concept. Now, this slide illustrates a really fundamental shift in how we have to think about software. A modern application isn't just one thing anymore. It's really two parts. You've got the application code itself, the part that actually does the work. But attached to it, you also have a security model, basically a set of rules that describes its expected behavior, which gets fed right into your monitoring system. So what's the ultimate payoff for all of this testing and all of this monitoring? Well, it's about creating a powerful cycle of continuous improvement. For decades, we kind of just threw code over the wall into this production black box and hoped for the best. But with monitoring, we create a feedback loop. We get a constant stream of data flowing back from production that directly connects the ops side of the house right back to the dev side. And that is the very heart of DevSecOps. And this feedback is a total game changer. With it, we can spot problems the second they appear. We can use real-world data to make our threat models smarter. We can build systems that can automatically react to security incidents. And maybe most importantly, we can finally prove that the security controls we designed are actually working the way we thought they would. This all leads to a really critical takeaway. Security is not some feature you can just bolt on at the end. It's not a checkbox. It has to be a core part of how we design, build, and, crucially, observe our systems from day one. Which means that, in the future, building software that can't be effectively monitored will be seen as a fundamental design flaw. And that leaves us with a final, big question to think about. We've spent decades getting really good at building software that can run at an incredible scale. The next great challenge is learning how to build software that can be effectively watched, understood, and secured while it's running. And that, right there, is the heart of modern security.